So for this video, we'll look at an interesting topic, which is finding the area under a curve y equals f of x, and by the use of the definite integral. And please recall the meaning of the definite integral. We learned how to compute it, and this video is more like an application of what you have learned regarding this definite integral. So let's look at the first case here. The first case is that f of x is positive. And it doesn't matter. So maybe I randomly draw a graph for the y equals f of x. So let's look at the graph here. Y equals f of x is there. And let's say now you want to find the area under this curve for the x-axis from A to B. So let's look at the shaded region like this. And the interesting fact is that we can actually find this area based on the definite integral. So the formula is that the area we have here for the shaded part is actually the same as the definite integral from A to B for the function given for the curve here. So you just have to do the calculation for this definite integral to find the area. And I would like to emphasize that this formula is only correct when the function is positive. Function is positive means that on the graph, the line always stays above the x-axis. And we'll deal with the negative case a little bit later. And let's do an example now. So please look at the current function, y equals 1 over x squared, and I plot the graph in purple line here. And let's say now I would like to ask you to find the area of the shaded region, which is bounded by the curve, and also from x equals 1 to x equals 3. And that's the shaded part we look at. And let's look at my hint here, and let's see how we can find the area. The area is gonna be the integral from 1 to 3 now. For the function, which is listed inside the purple box, 1 over x squared. And please recall how you find this net integral from 1 to 3 for the function 1 over x squared. You need to find the antiderivative of 1 over x squared. And please recall x to the power minus 2 is the same as 1 over x squared. So the antiderivative is going to be x to the power minus 1 divided by minus 1. So let's do this numerical calculation next. So we can actually express it in terms of minus 1 over x as a fraction. So for the first term in the bracket, I can replace x by 3. So it is minus 1 over 3. And the second term in the bracket is minus 1 over 1. So let's do this numerical calculation. So the answer is 2 over 3, right? And that's the final answer to this problem of finding the area. So the next part is we need to look at other conditions for the function of f. Let's say the function is sometimes negative. Let's see how we can find the area. So please look at the current condition where the function is negative. It means the purple line for the y equals f of x is totally below the x-axis. And in this case, I would like to find the area of the shaded part for x equals a to b. And because now the line is negative, the fact is that if you try to find the integral from a to b for the negative function now, it's going to be a negative number. But we can easily fix this issue. So let me write down the formula now. The area is actually a positive quantity all the time, and we just need to ignore the negative number, the negative sign of the number you have here. So that's why I'm using the absolute value sign for the integral from a to b for the function small f of x inside. And essentially, that's the formula we have when you find the area of a shaded region for a totally negative function. So let's look at an example now. So please look at the current picture, which is a parabola. The function is x squared minus 4. And of course, the y-intercept is minus 4 now. You're kind of pulling the parabola by 4 units down. So it's minus 4 for the y-intercept. And I would like to look at the shaded region, let's say from 1 to 2. So let's try to find the area of this part. And based on what I said before, let's look at the absolute value of the definite integral from 1 to b for the function x squared minus 4, right? And once again, it's quite easy exercise. We just need to find the antiderivative for x squared minus 4, which is x cubed over 3 minus 4x, right? And let's do this calculation together. For the first bracket, you need to replace x by 2. For the second bracket, you need to replace x by 1. So I trust that you're able to do this calculation on your own. So the answer is gonna be minus 5 over 3 inside the absolute value sign. So as expected, the answer must be a negative value. And after taking the absolute value, it's gonna be 5 over 3, right? And that's the final answer to this problem. So please look at the current function, which is x squared minus x. For this curve, the fact is that the x-intercepts are 0 and 1. So you can find it easily by setting x squared minus x equals 0. You can solve it yourself. These are the x-intercepts, 0 and 1. Anyway, now I want to find the area for the shaded part, which consists of two separate parts. So please look at this. Please look at this. They are separate. And please notice that for the part A, the purple line for the curve is actually below the x-axis, which means it's a negative function. And for the part B, it's different. It's going to be a positive part. So, and to deal with them, you have to always deal with them separately. You need to use the absolute value sign for whatever you have in the definite integral, right? But for the positive part, you don't have to take any absolute value sign because the answer you find for the definite integral must be positive anyway, because you see the part B is a positive function, right? And so for the part A, as I said, the function is negative, right? So you need to take the absolute value sign, and the integral inside is from 0 to 1. So I put it here from 0 to 1. And the function is given x squared minus x. So you need to do this calculation on your own. So the antiderivative for x squared minus x is x cubed over 3 minus x squared over 2 inside the square bracket is from 0 to 1. So let's do this numerical calculation quickly. So you see, as expected, if you don't take the absolute value sign, the answer is a negative number, right? And because A is an area which is positive quantity, we can drop the negative sign. So the answer for the area A is 1 over 6. So you see, that's the final answer for the area B. And as we expected, inside the absolute value sign, the answer is 5 over 6. So with or without the absolute value sign, it does not change the answer for the area B. So the total area is A plus B. A is 1 over 6, B is 5 over 6. So altogether is 1, right? So that's the answer to this problem. So let's look at the current problem. I give you the shaded part already. The shaded part is between the line y equals x plus 2 and the lower line is y equals x squared plus 2, right? And to find the area of the shaded part between the two curves, the fact is that you can think of it as you are finding the area for the bigger part first. So I use the red color to represent the bigger part. It is based on the upper line, right? So and then for the lower line, which is this one, the lower line, if you integrate the function corresponding to this value of AB, the lower line, which is this one, the green line, will correspond to this area. So I hope you get my point. So basically, I'm saying the following fact. I'm saying that for the red part, the integral is gonna be from A to B for the function x plus 2, which is the upper function. And for the lower function, it's gonna be integration from A to B for the function x squared plus 2, right? So the fact is that the red part is the bigger part, the green part is the smaller part. And as you can see what's happening, if you look at the red part, you subtract the green part out, it's gonna be the area I want, right? So now the remaining fact is that you have to find A and B. And I wish that you know how to find A and B because we have two lines. And finding A and B is the same as solving for the intersections between the two lines. Mathematically, to solve for the intersections, we can bring the two equations together. We can make them the same. So x squared plus 2 equals x plus 2. The 2 is cancelled. You're solving this equation now, and which means x is 0 or 1. So that's the values for a, and b is 1. So it means that now we can look at what we need to do here when a is 0, b is 1. So the area formula is that you have to find the upper area minus the lower area, corresponding to the upper function and the lower function respectively, right? And I trust that you're able to do this calculation for the antiderivative of this function is x squared over 2 plus 2x. and you have to replace it by 1 and 0 correspondingly and find the difference of them. And similarly, for the second one, it's going to be x cubed over 3 plus 2x. And once again, you need to find the value of this function from 0 to 1 and take the difference. And the remaining is a purely computational exercise, because you see, when the upper and lower limits are the same, the 2x can be cancelled, right? So basically, you are left with this calculation from 0 to 1. And I trust that you're able to do this calculation quickly. The answer is going to be 1 over 6. And that's the final answer to this problem.